Good morning if you're in the Pacific Southwest, Northwest, I should say. This is Kelly Kay from Microsoft. Welcome to our Power BI webinar. It is Tuesday, July 9th, 2019. Our webinar today focuses on unlocking petabyte scale datasets in Power BI with aggregations and its upcoming general availability. Today, we're going to be walk through this wonderful feature by Christian Wade. Christian is a program manager here at Microsoft. He drives enterprise features in Power BI and analysis services. Along with Christian today on the call, we have Vijay Gopala-Christian. He's also a PM at Power BI and also drives enterprise features in Power BI and analysis services. Vijay will be helping here answer the questions, and Christian will be walking us through the demo. So hi Christian, how are you?
I'm very well, thanks. Kelly, how are you?
I am great. Really appreciate you taking the time today.
Thanks for having me.
Also, hi.
Very excited to be here.
So let's jump right into it. So there is more and more data available for decision making nowadays, and I'm tempted to ask you, how can organizations unlock the value of this data for non-technical users?
Funny you should ask, Kelly. So that's what we're all about, right? We are about putting data in the hands of decision makers. Nice and easy peasy. Just put it right there in the hands of the decision makers. Non-technical skills don't require, for the end users, they don't require learning how to write queries. They don't require intimate familiarity with the data structures. They just clicky, draggy, droppy, absolutely beautiful reports in minutes. That's what we're all about, Kelly. So yeah.
I'm super excited. I've heard a lot about the clicky, draggy, droppy demo. I've heard so much about it. I'm dying to see it. So
all right.
So let's see your demo.
All right. So I'll start off with the clicky, draggy, droppy demo, and then we'll move into how to actually set up aggregations. I'll talk about it initially at the kind of conceptual level, and then do an actual demo of setting up from scratch. And then I'm going to focus on the new feature that no one has seen, which is, or the new part of the feature, which is how aggregations works with row level security. All right.
Excellent.
Okay. So that's the new bit that no one's seen yet. So let's do this demo here. So here I have, some of you may have seen it, many of you may not. I'm always surprised at the number of people who have not seen it, this demo, but here we go. So this is data for a crowdsourced courier service where a smartphone app emits the driver's location. So each row in this driver activity table represents an individual location. And as you can imagine, these apps generate a ton of data. So each row in this location count measure, as you can see here, is simply, this location count measure is simply the count of the rows in the table. So let's figure out how many rows we have in here. So let's casually drag it onto the canvas. Just another day at the office. Everything looks completely normal.
Clicky,
and lo and behold, we have over 1 trillion rows of data. This one is over 1/4 of a petabyte of data coming from an Azure Databricks 12 node Databricks cluster. This is beyond what most organizations actually, by the way, you don't need 1 trillion rows and 1/4 of a petabyte of data to make use of this feature, but just to show you that there is, for all intents and purposes, no upper limit in terms of the scalability that we can achieve with this feature. All right, 1/4 of a petabyte of data, 1 trillion rows coming from Databricks. And as you saw, we got instant response times. So I'm going to go ahead and break out the distance traveled. I'm going to make it a bar chart. I'm going to break it out by date. I'm going to make it nice and big. I'm going to break it out by the miles per job. I'm just getting instant gratification. I'm going to go ahead and filter it just by the drivers who left the company. As you can see, this is clicky, draggy, droppy data analysis over massive data sets. That's how we roll. All right, so I'm now going to go ahead and filter this by December 23rd, and I'm going to create a list of the drivers who performed a job on December 23rd that was over 50 miles and subsequently left the company. All right, so I've just done that interactively over 1/4 petabyte of data, instant response times, without writing any queries, just as a complete non-technical user, I have access to this data. We're really unlocking these massive data sets in enterprise organizations. So I'm going to come down here and I'm going to find my good friend Abigail Johnson. Where is she? There she is. And what I'm going to do now is I'm going to drill through to the detail records for Abigail Johnson. So up until now, it's been blazing fast because we've been hitting the in-memory cache. But the reason this is possible is that we cache the data at the aggregated level, right? Whereas now I've drilled through to the detail level where there is no cache. So it's actually submitting a direct query to the Databricks cluster. And I need to get this thing out of the way so I can get to my Databricks UI. Just one second. There we go. There we go. All right. And so here we should be able to see the query actually running.
Wow.
And so here we have a query against the 1 trillion row table. It's almost done now. And so here's the filter for Abigail Johnson. If we come back here, we can see that the data's loaded. So basically, we got blazing fast performance while we were querying the in-memory aggregated cache.
Mm-hmm.
When we drilled down to the detail level, there was no cache. And then it just submitted a direct query to the source, to the Databricks cluster. We got a seamless experience for the users. And the reason this is possible is because of this feature, right? We are not going to cache 1/4 petabyte into memory. So what we do instead is we just cache it at the aggregated level and we still unlock these massive data sets. So here we can see Abigail Johnson drove across Memphis and then she subsequently left the company. And I like to think that she started her own company. But the point being, as I say, we unlock this massive data set in a way that would otherwise be physically impossible. Okay, so let me get back out of here. And so I think what we'd like to talk about next, Kelly, if you're okay with it, is how to set this up.
Oh, I'd love for users to know how to set
Yeah,
it up.
so let's just talk about it. How do we set this up? So up until last year, I think it was July of last year, a Power BI data set was either in direct query mode or in import mode, and you could not mix and match the two.
Yes.
All right, so the concept here is that when the data set is in import mode, we cache all the data into memory, right? We use a column-oriented in-memory compression. We get very high compression ratios, and then that's when we get this blazing fast performance, right? But even without compression ratios, these kind of volumes like 1/4 petabyte or even in the many terabytes, which is probably more common for many customers, it becomes really expensive to cache all that data into memory. You not only need a lot of memory, so you need some big machines, but also the management overhead of replicating all that data into memory becomes a challenge. In many cases people do it. So for example, in Azure Analysis Services, we have the S9 SKU with 400 gigabytes of memory, and you can fit many terabytes of uncompressed data, and once it gets compressed you can fit that on one of these big servers. But A, they cost a lot of money, and B, it costs money in terms of the management overhead of replicating that data into memory. So the other option is you don't cache the data into memory. You keep the data set as a direct query data set, which acts as like a pass-through layer, and then as users interact with the visuals in Power BI, it generates DAX queries to the data set, and the data set then just translates that to the SQL query to the data source and gets the data from the data source in real time. Excellent. Like we saw the query running against the Databricks cluster. And that's fine for some data sets, but then the problem is, especially with some of these bigger data sets, the performance tends to not be that good. So what we did in July of last year is allow you to mix and match the import and direct query storage mode at the table level. So now you can pick and choose which tables to cache. So you get a much better bang for your buck in terms of
Wow.
memory consumption. This is really a game changer from that respect. And then the other thing that you can do is on top of this is what we call the composite models, the direct query composite models feature, where we can mix and match direct query and import. We can have multiple direct query sources. And on top of this is the foundation for aggregations. So for aggregations, let's pretend that the sales table has 10 billion rows. And so it would be very expensive and time consuming to cache it into memory. So what we can do is we can create an aggregation table that is in this simple case is just the sum of sales grouped by date ID, geography ID. So this will go down from, in this simple case, from 10 billion rows down to, a few million or 100 million or so. Much easier to manage, much easier to optimize.
So it's an a la carte data set.
It's an a la carte data set, absolutely.
Excellent, excellent. And Christian, I'm always interested about security. I'm not sure if you're going to cover that right now or later.
Yeah, I'm coming on to that. So so we will cover that, because when we launched this feature in public preview, I think it was August of last year, just after the composite models feature, up until now, it has not worked with row level security because there was some extra work. So it was in public preview. So this was the final piece of the jigsaw to get aggregations to general availability, is to make it work with row level security. So that's exactly what I'm going to cover in just a short amount of time.
That's fantastic.
Okay, cool. So we've got the sales aggregation table, and it's an aggregation of sales. And the users, the consumers, the queries, they know nothing about this sales aggregation table. They just submit queries and generate visuals in Power BI, right? So as you generate visuals in Power BI, it's going to generate a DAX query to the data set. So this is a DAX query. And this is simply asking for the sum of sales grouped by year and city. Right, so it doesn't know anything about the aggregation table. It just asks for the sum of sales. And because year and city happen to be in the 2-dimension tables that relate to the aggregation table, the engine internally, based off the metadata mapping that you set up, the engine internally is going to redirect that query to the aggregation table without the user having to know anything about it. The only thing the user knows is that the performance is blazing fast over a 10 billion row data set. That's
Excellent.
it, right?
Excellent.
Yeah. So then it hits the cache. And then what happens, you may ask, if the user submits a query that cannot hit the cache? For example, one that asks for the sum of sales by customer. This is kind of like when I drill down to the detail records and view the actual locations for Abigail Johnson on that date, right? It's now at the level where it cannot hit the in-memory cache. So what's it going to do? Just like in the demo, it's just going to seamlessly switch over to direct query, and the users have a seamless experience. The users don't even need to know which query is a direct query or import, right? So this then switches to direct query, and then it generates a SQL query against the source system, and it gets that data in real time. Make sense?
That is fantastic. Absolute perfect sense. And I just wanted to say Abigail Johnson is a fictitious person, no relation to anybody at Microsoft or outside of Microsoft or anywhere.
She's a fictitious person. She's doing very well now in my fictitious mind, or in my fictitious world. She's like got her own company now, and she's doing very well. I like to think that anyway. Okay, so that's the concept of it.
So we've covered. So now we've covered. We've covered the basic features, the aggregations portion, the security now available for aggregations, row level security now available for aggregations. What else have we summarized here in the last couple of?
Okay, so this is just what I've summarized here is the high level concept.
Yes.
So what I can do next, if you want, I can actually create an aggregation from scratch and then show some queries that hit and miss the cache, and then actually create some row level security filters and show you how that all works together.
I think that'd be great, actually.
Yeah, because so for those who don't know, we are planning to make aggregations generally available in the July desktop release that's upcoming in very close. So we're very close to the general availability of aggregations, and it will then work with row level security. So the version of desktop that I'm going to use is a build that is basically the same build that you'll get in the July desktop release.
Great.
Okay.
That's great.
All right. So let's switch back over here.
I just have a quick
it.
pause here.
Yeah.
Are there any questions, VJ, that we need answered now before we go on that relate to the next session or at all?
No, we do have a few, but I think given the flow structure, perhaps we can do it at the end of the session.
Okay, great. Let's do that.
Okay. Yeah, we'll definitely reserve some time to answer the questions.
Excellent.
All right. So I've got this data set here. So here, these tables are exactly the same tables that I have in my data warehouse. So I've, it's a one-to-one relationship with the tables in the data set versus the data warehouse. These tables are all direct query right now. You can see over here the storage mode. If I just zoom in here, the storage mode is direct query on all these tables right now.
Great.
And I have this sales ag table. So this sales ag table is an aggregation of the sales table, right? So there are some columns in here which are foreign keys to the other dimension table. So we've got, so if you imagine you take sum of sales and you group by customer ID, you group by date key, sorry, customer key, date key, and product subcategory key. That's going to define the granularity of the aggregation tables, So the non-foreign key columns are the aggregated values, right? The sum of sales, the count of unit price, etc. We get very good coverage in terms of, the aggregation functions you set up in the aggregations dialog are sum, min, max, count, and count of table rows.
Okay, let's go through that again.
Yeah.
Sum, min.
In fact, let me just bring it up and then I'll zoom in and actually show you. So let's come into manage aggregations, and if I find the sum of sales amount, and if I show you here, so count is disabled. There's a ton of validation, so you can see that it's validating on the data type. There's actually a ton of validations in the tooltips. That's a little tip for you. Look at the tooltips because there's lots of information in the tooltips. So here you can see we've got count, group by. We'll come back to that in just a moment. Or group by is optional for foreign keys, but you can actually use it to make distinct count work, right? You can even make distinct count work with these aggregation tables, believe it or not. That's a bit more of an advanced topic, so we'll save that for another day. But you get much better. You can make the average function work in DAX. Wow. But if you have a sum and a count internally, the engine will just divide the sum divided by the count, right? You've got sum, min, max, count, distinct count, average. There's a ton of these DAX aggregation functions that will hit the cache, and it works for complex calculations as well. Ultimately, these complex calculations get kind of folded down to individual storage engine queries for sum, min, max, and count, and so you'll get good aggregation hits on complex measures, right? So here we've got count, group by, and group by can be used in more advanced scenarios for big data scenarios where you don't actually have relationships and you can still hit the aggregations. That's another topic that's in the documentation, where some of these Hadoop based big data models don't have many relationships. They've got very denormalized tables that are kind of like file headers and you can't rely on the relationships. Well, you can still hit the aggregations with those models using group by. But as I say, we'll have a further info section at the end. And
talking about count distinct, actually, going back to that, that's always been a problem. For aggregations, and you're saying that this.
So what you can do is, if this is a bit of an advanced topic, but if I were to set up a group by on the foreign keys and then I do a distinct count of customer key, it would know that it can retrieve that distinct count from the aggregation table because the distinctness of that column is covered in the aggregation table. So you can get a distinct count to hit the aggregation. All right. So these are the other there's a ton of DAX functions here that will hit the aggregations. Right, not more than just sum, min, max, and count. So I'll go with, this is for sum of sales. I'm just going to set this up as the sum of the sales table. And you can see up here, you've got the summarization detail and table and detail column, right? So I'll go with the sum of sales amount, right? So what we're saying here, by the way, these are the same columns that you see in the aggregation table, right? So what we're saying here is that, this column right here, the sales amount sum, which is the one we just set up the aggregation for, is an aggregation of the sales amount column in the sales table, which we can't see right now, but it's in there, right? So it's a sum of that other column at that aggregated level.
Excellent.
All right. Okay. So we'll go ahead and do that. And then it's saying, oh, if you do this, then the table is going to be set to hidden, right? So that's fine. The reason it's being set to hidden is that as of the July desktop release, you can see it just got set to hidden here, and it's now grayed out because it's set to hidden. So as of the July desktop release, that now it works with row level security. If you are not the equivalent of, so this is running on an analysis services instance in the background, right?
Yeah.
So if you are not the equivalent of an analysis services admin, you can, so in other words, if you've accessed the data set through a role in the Power BI service after it's been published, then you can, no matter what, even if there are no RLS filters, you cannot query the aggregation table. And there are security reasons why we've done it that way, okay? So for that reason, it makes sense to always have it hidden. You don't want to have anyone encouraged to query the aggregation table. The aggregation table is completely abstracted from consumers. The consumers just query the big sales table, which is why it's automatically hidden for us, okay? So now I've set up the aggregation, but everything is still direct query right now, right? All of the tables are still direct query. So I'm going to go ahead and I'm going to run this query, right? So I ran this query earlier, and when I ran it earlier, this is just asking for the sum of sales grouped by geography, country, region, code, and we got back these values. And using this fantastic tool, DAX Studio, it will show us because everything's in direct query, it's showing us the SQL that is being submitted to the source, right? So when I ran this before I even set up the aggregation, as you can see, it queried the big fact table. So let's pretend this table has like 10 billion rows or something in, right? Obviously it doesn't, because I wouldn't be able to set up the demo from scratch, but let's put the fact internet sales table is the big one. Let's say it's got 10 billion rows. So without the aggregation setup, it's querying the big one, right? Now, if I rerun this same query, having set up the aggregation, we should get back the same values, but now we actually got an aggregate rewrite attempt match found. And if we look at the direct query that was submitted this time, it did not query the big 10 billion row table. Instead, it queried the aggregation table, right? As you can see here, it actually queried the aggregation table. So this, without even using the in-memory cache, the import capability, just keeping the whole thing as direct query, this is already a game changer, right? Absolutely. This is already, you can already optimize the aggregation table, which is going to have maybe 100 or maybe a few million rows instead of 10 billion rows. Much more easily, right? You can put indexes on there, you can put column store indexes on there. That thing could be a materialized view. So I think I saw a question earlier about how this can be enabled on top of transactional systems. Yes. Well, with direct query, you can have near real-time interactive analysis over massive data sets that actually gets it the updates quickly, because if you keep the whole thing as direct query and maybe the aggregation is a materialized view, then the materialized view will automatically reflect any changes to the big fact table, right? Wow. So if you leave the whole thing as direct query like this, you're going to enable near real time, and you're going to actually have a nicely performing experience for the end users, right? So this alone, even without the in-memory, is already a big deal, right? Okay.
Fantastic.
Cool.
Super lightning speed.
Yeah, lightning speed. That's how we roll.
That is amazing.
Cool. So the next thing I want to do before I jump into the RLS piece is I'm going to actually set this table to be import, right? So I'm going to set this to be import. Now, when I set the aggregation table to be import, it's saying, if I want to set this to import, it strongly recommends that I set the related dimension tables, so only those which can filter the aggregation table, so that'd be geography, customer, product category, and product subcategory, not product, right? It's suggesting that they get set to a storage mode of dual, right? So what does dual mean? Dual means that the table can flip back and forth between import and direct query, right? So that when we get a query that asks that hits the in-memory aggregation and it asks for sum of cells grouped by geography region code or something, that whole query is going to hit the in-memory aggregation, including the columns from the geography table.
Okay.
Right?
Yeah.
But when it has to revert to direct query, when it can't hit the cache, and it still is grouping by the geography region code, then the geography table then switches to direct query as well.
Yep.
It's much more efficient for it to either all be import or all be direct query, so that it can push those group by, those joins and group by operations down to the source system. It's much more efficient than trying to do the join in the Power BI side.
You know, I did see a question pop
Yes.
up, and it's
Okay.
a question that I also have
Go
with
for it.
regard to measures and creating measures on these data sets. So
Yeah.
are we still able to do that?
Yes, absolutely. You can create measures just like you normally would. So the measure would refer to the big sales table, and internally the engine will just magically redirect to the aggregation table, and you get blazing fast performance. Even complex measures will it will create a query plan for complex measures and figure out once it folds all the components of the measure down to the sum, min, max, or count, whether that can hit the aggregation. If it can, it will just hit the aggregation with that. Yeah,
That's
cool.
amazing.
Okay, so now I've set this table to import, and this is about as complex as it gets, by the way. If anyone has a background in analysis services multidimensional, and you know aggregations in multidimensional, this is way simpler and a lot more powerful, right? Because the aggregation is just another table, so it can be in direct query mode. It can leverage externally defined aggregations. You know, the architectural options are way wider than it was in multidimensional, and it's a lot simpler. Because once you've set up this model, you know when you're going to get ag hits, right? You know you're going to create an aggregation table that relates to the dimension tables that are commonly used, the high value. You know, you've done your Kimball bus matrix. You know which of the dimensions that are used by your executive dashboard, which are the dimensions of the high priority business one, the high priority from the business standpoint. And so you're going to optimize for those, right? And then you know exactly when you're going to get aggregation hits, because the fact that you set up this model means you understand it. It's not like a black art trying to figure out when you're getting aggregation hits, right? Okay, cool. So we set up this table, it's import, and the related dimension tables, as you can see, the storage mode is dual, so they can flip back and forth between import and direct query in terms of what is the most efficient for each particular query. And the ones that did not need to be set to dual, they're still direct query. So everything else, right? Promotion, the big 10 billion row table, everything else is direct query, right? So we're using that composite models feature where we can at the table level set the storage mode. All right. So having done that, I'm going to run the same query again, right? And we should get back the same data, but this time we also got an aggregation hit, but this time we got a scan instead of a SQL. So this time it did not submit a SQL query to the source. Okay. It just came back from the in-memory aggregation. And how long did the storage engine query take? It took 11 milliseconds. Right? So as you can see, in my opinion, we've got the fastest BI engine on the planet. You know, like the Vertipack in-memory column-oriented analysis services tabular engine is blazing fast. So you're going to get really fast. You know, clicky, draggy, droppy. That's how we roll, right? It's because of this in-memory Vertipack engine that we have. All right. Okay. So we've set that up, and then you may ask, well, what happens if I submit a query that cannot hit the cache? This is the last bit I'm going to show before I show RLS. So I'm going to run this query. This query is exactly the same as the previous one, except instead of grouping by country region code, we are grouping by the promotion, English promotion name, right? So if I quickly show you over here, promotion is all the way over here. It can't relate to the aggregation table. There's no way we can hit the ag if we're going to group by promotion, right? So if we run this, what's going to happen? Is it going to, say, sorry, you have to learn Spark SQL? No, it just runs. It just runs successfully, right? So here we get the sum of cells grouped by promotions, and here we said it considered the aggregation, but it said, sorry, we can't hit the aggregation because we are not at the granularity that can use the aggregation, right? And so it just on the fly reverted to direct query, no problem, just reverted. This is exactly the same as like when I showed Abigail Johnson's locations on the map, It just submitted the direct query, right? So here we see that it ran against the big table, okay? So that's a crash course in aggregations. I didn't cover the big data models. I didn't cover all of the aggregation functions. I didn't cover all of the DAX functions that can hit or miss. But the basic concept, I think if you've understood what I've just explained, you're 80% of the way there, right? Yeah, you know, the basic concepts are there. That's the foundation. The rest you can probably look up, and we'll provide some resources later in terms of further information. So the next bit that no one's seen yet up until in a few moments from now is how this all works with row level security, right? So when I connected this query window in DAX Studio, if I show you down here, I'm actually impersonating a user who was a member of a role called Aggs Test. Right, and so if I come into the model over here, let me just reconnect this. So if I come into the model and we come into the modeling area, up until the July desktop release, the manage roles button is disabled because it says you've got aggregations in the model, you can't even use RLS, right? Yep. Whereas now, as you can see, it's enabled, right? So I'm going to come in. And so currently I've got just this Aggs test role, but there aren't any RLS filters on here right now, right? So up until now, it hasn't been having any effect at all. So let's start creating some RLS filters and see how it works. So the first one I'm going to create, I've got over here, is geography country region code equals US. I'm going to put this as a filter on an RLS filter on the geography table, right? So as you can see, the geography table is up here, and the geography table has a filtering relationship. It's on the one side of a one-to-many relationship to the customer table, and the customer table has filtering relationships to the aggregation table and the big 10 billion row fact table. This is how you want to set it up, right? You want to set it up so that your RLS filter or your RLS filters can filter both the aggregation and the detail table, right? Otherwise, I'm going to show you what happens if it's not set up like that, but this is exactly how you want to set up. You want to make sure that the RLS filter can apply to both. So if I do that, right, and I now run this query again, we will see we're only getting cells for the US, right? And the good thing here is that we still hit the aggregation, right? We still got a scan and it still hit the aggregation. Why? Because it was safe to hit the aggregation, because the RLS filter could be applied. The RLS filter was applied, right? As you saw in the output, right? So because the RLS filter can be applied to both the aggregation and the detail table, it just works the same as before, but you just apply RLS, right? So we only see the data for the US. And when I hit the aggregation, it still applies the RLS filter. And if I don't hit the aggregation, it still applies the RLS filter. In fact, if I run this one that doesn't hit the aggregation, and the output is grouped by promotion, but this is now just the cells in the US, right? So now it reverted to direct query. And if we look at the direct query itself, you can see here that even in the direct query filter, based on the privacy levels in Power Query, it's actually filtered the source on US data, right? Wow. So whether it hits the aggregation or not, it's applying the RLS filter, everything's good, right? Because the RLS filter can filter both. So what then happens if I set up an RLS filter that cannot be applied to both the aggregation and the detail table? So let's say if I set one up on the products table, right? So let's come in here. Let's say that for whatever reason, it's okay for general users to know about our red products. Okay. But if it's not red, it's top secret, highly confidential. Okay. Right? The non-red products are, not for general consumption. Okay. Right? So we want to put this filter on the red products. And so if we look here, this is on the product table. The product table is not at the granularity that can hit the aggregation. Right, this is a problem, right? Because we cannot redirect to the aggregation table, because otherwise we'd be disclosing secured data, right? So the data in aggregations is another representation of the same data in the cells table, and it would not be able to apply the RLS filter. That would be a problem, right? Hopefully that makes sense. So I go ahead and do this. So it accepts it. And now if I run our query again, the one that was hidden the in-memory cache before, we now get red product sales in the US, but it was unable to hit the in-memory cache. It had to revert to direct query. And in fact, we can see here in the query itself, it filtered on red products in the US, right? So as soon as you have an RLS filter that can filter the detail table, but not the aggregation table, any user who is a member of that role will not get aggregation hits, which defeats the object, right? So, so that's the main problem. You need to make sure it can filter both. So then you may ask, well, what if we create an RLS filter that can filter the aggregation table, but not the detail table? Well, this one actually makes no sense, right? Because what you're saying is, okay, the users have access to the big table, the detail table. The aggregation table is another representation of it. The aggregation table is the one, in the background, and that one's secured, but the one that everyone can see is not secured. This makes no sense at all, right? So if I try and do this, try and put a filter on the sales ag table itself, it's just going to say, sorry, that's as much as I can deal with. It's going to say, time out, I can't deal with this now.
Danger, Will Robinson.
Yeah. So Houston, we have a problem. I'm just going to back out. I'm going to say, sorry, this makes no sense. I'm a computer, but I know enough to know that this makes no sense. So it's going to actually disallow that. All right. And that is it. Like RLS and aggregations, they do have some kind of complexities in the way that they work together, but we've kind of honed in on the key scenarios there, and we've got some validation in there, and that's it. So in the July desktop release, as I say, RLS will work with aggregations, and literally the biggest scalability feature in the history of Microsoft BI, I think that's a fair statement, will be generally available, and it will work with row-level security.
I am so happy about this feature, especially the security option. As you know, I'm loving the security features that we have in our products. I'd like to know, how do people get their hands on this? Yeah,
good question, Kelly. So this will be coming out in the July desktop release. So Amanda Kofsky does a fantastic job of doing the monthly Power BI desktop blog post. So Amanda Kofsky will officially announce it in the July desktop release, and then we'll do another follow-up post later. And for further information for some of the more advanced features that I glossed over, if I come over to the slides, here we have this is a link to the documentations, aka.ms/aggregations. This covers all of how you optimize it for big data models with no relationships and all of the different aggregation hits, etc. Here is a recording of the good old Trillion Row demo. I can't remember if this was the original one or not, but anyway, I think that was the actual original. And of course the Power BI blog, where Amanda will announce the July desktop release.
Fantastic. And then we can also answer any other outstanding questions and post them on the blog straight after. I think Vijay has something on the couple of questions that we could answer.
Sure.
Here we are.
Let's do that.
So let's take it, or
sorry, which ones?
There.
Do you want to
just up here?
read them out?
Sure. Why don't I read them out?
Yeah.
Perhaps. So first one is, does the actual data reside in memory, the database cluster, or where is it stored?
Okay, good question. The data resides in the analysis services instance that Power BI is running on, right? So the Power BI datasets are literally powered on analysis services, which is our BI engine, which is now over 20 years old, has been a market dominator for decades. We're the only vendor to be ranked in the leaders quadrant in Gartner's Magic Quadrant for BI analytic platforms for the last 12 years. 12 years ago, self-service BI barely existed as a discipline, which shows our heritage in enterprise BI. So we've got 20 years of heritage in analysis services. Power BI datasets run on analysis services. So when you cache that data into memory, it caches it into the analysis services engine that the Power BI dataset is running on.
Perfect. Thank you. So the second one is, and there's quite a number of people actually ask this question: is this functionality available for backends other than Databricks, SQL database, BigQuery, Redshift? I know we've done this with Azure SQL Data Warehouse before, but
Yeah.
how about this other?
Yeah, it works for all of the direct query sources in Power BI. So there are some optimizations that only work on SQL, but it absolutely works. SQL, Oracle, Teradata, Databricks, Spark, all of the direct query sources in Power BI.
Yeah. We have another question that comes up sometimes, which is this session being recorded? Yes.
Good.
And it will
Yes.
be posted to, I believe, our blog, or
Yes.
the link will be posted to our blog.
Yes, we will do a blog post following Amanda's blog post, and we will provide a link to this recording. That's the plan. Yeah.
Excellent.
I got a few more.
Okay, sure. Let's go for it.
Sure. Next one is, can aggregations work with Power BI data flows?
Not at this time, I believe, because it only works with direct query sources, right? So they may be enhancing that to support direct query. I'm not actually 100% sure of the timelines or the status of that, but it needs it. So the data flows runs on ADLS Gen 2, and so you need a compute engine typically to support direct query. So they may be putting a compute engine on top of data flows, but in the meantime, if you had a direct connection to ADLS Gen 2, it would not work given that there's no compute engine, so there's no direct query. It requires a compute engine for direct query. Yeah. Okay.
Got it. There's another question on, with regards to the demo. What's the size of the Databricks cluster?
Okay, so the Databricks cluster, I could even show you if you want. The Databricks cluster, if you can still see the screen, and I come over here, the configuration is between 12 and 15 nodes. So it's quite a beast. It's quite a beast. But it's got quarter of a petabyte of data. So it's 12 to 15 node Databricks cluster. Yeah.
Wow.
Perfect. Another one. Any ETA we have when we have direct query on data flows?
I don't know. You'd have to ask the Power Query program managers for that.
Sure.
All right.
That. Okay. There was one question on if you had a plan to count distinct. Now I know we addressed it in a certain fashion, but there's also there's a follow-up asked for a strong need for distinct count if the primary key to a sales table is in an order line and the company wants to, let's say, count orders without grouping by orders.
Yeah, so if you've got a couple of options, right? So to dig a little deeper to the direct query.
Can I?
Yes, go ahead.
I apologize. Can I just ask? Do you think everybody can hear? Because I think you're a little bit far from the speaker. Maybe it's probably to come closer. Fair. And let me repeat that question. There's a strong need for distinct count if the primary key to a sales table is an order line, and a company wants to count orders without grouping the order number. Grouping by the order number defeats the purpose of an AGS table.
Right.
Is that
okay?
That was the one.
Yes.
Okay. So if the order number is the distinctness of the order number is too high granularity to persist into the aggregation table. So I think the rough benchmark is between 2 and 5 million values, which is easy to persist that into memory. But even when you get that into memory and you have beyond, say, 5 million order numbers, the distinct count, even on the in-memory cache, tends to sometimes have performance issues, and this is due to the physics of distinct count, and this is a problem that every vendor has. And one of the ways that you can overcome that one is you can actually set up an approximate distinct count, which is already supported in SQL, and we have it on the backlog to support it for in-memory caches as well. And so you can have an approximate distinct count, and you may have a margin of error of maybe 2 or 5% or something, or maybe 2%, but then you actually get equivalent to some function performance on distinct count. So I'd say if you're up to 5 million distinct values, You can absolutely put it in an in-memory aggregation table, and then keep the big table as direct query. That's a big step in the right direction for distinct count anyway. And beyond that, as I say, you can set up approximate distinct count for the direct query distinct count against the source, and we plan to support approximate distinct count, but in memory caches as well.
Okay. Got it.
Okay.
Thank you, Christian.
Okay.
Just a few more.
Sure.
When will the Ag tables work with Power BI report server?
You'd have to ask Chris Finland for that, I'm afraid. You'd have to ask the PM for Power BI report server, I'm
Perfect.
afraid.
I'm happy to follow up and I'll post that back.
All right,
here.
no worries. Okay.
How are you able to switch storage mode? Previously was mentioned that this model connects through AS, and I thought that live connection was the only way to connect to this.
Okay, so there's I haven't got an architecture slide that I can bring up easily, but basically people need to, this is a common area of misconception or misunderstanding that just needs a bit of clarification, right? And it's totally natural. So when we say live connect, that means that you are connecting, say, from Power BI desktop to a Power BI dataset or to an analysis services dataset, and you are using Power BI desktop just for the reporting side of things. You're not using Power BI desktop to create a data set, right? So therefore you just create the report and it just does a live connect to the Power BI dataset, and it just submits DAX queries to the Power BI dataset in real time. Direct query is another thing which is on the Power BI dataset itself, right? It's not a property of the report. It's not a property of how the report connects to the dataset. It's a property of the dataset itself, or even of the tables within the dataset, right? So the tables within the dataset are set to direct query or import. So therefore, whether the user is connecting using Live Connect or not, right? There will be DAX generated against the data set, and the data set, depending on whether it's import or direct query, will either answer the queries from the in-memory cache, or it will translate those DAX queries to the native SQL construct for the data source, and it will pass that query through to the data source and get the data back in real time. So those are the difference. Hopefully that's clear. This is easier to explain with an architectural diagram, but as I say, Live Connect and direct query are two different things. Okay.
Fair. Just a few more.
Sure.
Okay, because you have an aggregate table, in cases where you have a very Snowflake schema, does query performance improve when hitting those further distance dimension tables?
Yes, absolutely. So Snowflake schemas work nicely with aggregations. Like the model that I had was fairly Snowflake. So you know, this is the old dilemma. We all want to get to a nice star schema. We want to have like completely denormalized dimension tables against our big fact table. But what happens when you have another fact that comes in, which is at a higher granularity? It forces you in many cases to implement some normalization on the dimension tables, right, which forces you down a bit of a Snowflake path. So put in that aggregation, it's the same kind of dilemma. You need to, it's kind of like modeling a fact table, and then you need to sometimes normalize those dimension tables a little bit to be able to allow for that aggregation table, just like you would in a Snowflake schema. Now, that's not mandatory, right? So this is an advanced kind of modeling concept which is covered in the documentation. There is another way of doing it, which is based on those group by columns where you don't depend on relationships, right? So if you're doing it the Snowflake way, you're depending on the relationships. There's another way of doing it where you use the group by column. So for example, if I've got an aggregation table and it is grouped by product subcategory and geography and month, right? So let's say it's grouped by month, and I do not want to normalize out my date dimension table, right? Because it's just not the done thing. I want to keep my dimension table completely denormalized. I don't want to create a separate table where the granularity is month, and then another that relates to another date dimension table where the granularity is day, and then have the aggregation table relate to the month date dimension table. I don't want to do that. So what I can do instead is I can replicate month, quarter, and year in the aggregation table, and then I set up those group bys on month, quarter, and year, and I still get aggregation hits, right? So this is Yeah, this is how you avoid having to normalize your dimension tables where it's too expensive or it just doesn't make sense, right? So this is the whole snowflake versus star schema. It works with both. In fact, if you look at the big data models, you'll often have like one big completely denormalized fact table where all of the dimension attributes are replicated in the fact table, kind of like a big file header with no relationships at all. And then you create an aggregation table on that is the sum of the measure and a subset of the dimension attributes. That's just a completely independent table. There's no relationships or anything. So you have to use those group biases to make that work. Right? In fact, that's how the trillion row demo is set up like that on Spark. Right. Okay.
Got it. Two more and okay.
Sure.
Are there many limitations in direct query with DAX and such? Are some of those being lifted?
I wouldn't say that the limitations are that big. That it doesn't allow inter-row DAX functions on calculated columns. There's a few corner cases like that, but I wouldn't consider them as major showstoppers. You know, I think probably the bigger impact on or the bigger limitations are things like you know, you can't have incremental refresh on a direct query table. That makes no sense.
Sure.
But there are some power query limitations that it needs to be foldable direct query. It needs to be foldable M expressions for it to work with direct query. So probably the bigger limitations are around power query and M. I don't think the DAX limitations are huge, in my opinion. Yeah.
Perfect. And so one more, which is this on Power BI Premium only?
No. This is actually, so thank you for that question. This works in shared as well. And we absolutely want to have modeling symmetry between Power BI Premium and shared. Not all of the features currently, like, you know, the differentiator for Premium should be, you know, scalability in terms of dedicated cores. And we'll you know, eventually when we get to load balancing and you know, scale out, etc., those will be genuine Premium only features. But in terms of modeling parity, something like incremental refresh, we'd absolutely plan to put incremental refresh in shared. It's just a question of prioritization to make that happen. And aggregations and composite models already work in shared stroke pro capacities. Yeah.
Perfect.
We have a couple more minutes left. I think we can probably take
sure.
2 or 3 questions. I know that there's a few published ones as well.
Yeah.
Let me go back to those.
Do you want me to? There we are.
Oh, there we go. Okay, and we actually did. You did touch on in this mixed mode. Can we do measures on direct query pieces? So
yes, you can.
Yeah. Also, I think this. Let me quickly sieve through these and make sure. Okay, so this one more, which is there a reason that the filter all contains value logic does not work with aggregate rewrites? Are certain functions not allowed? You know, so the user attempted this for a prior metric, but was only able to make it work with user relationship.
Okay, it doesn't actually. We'd have to look at the specifics.
Yes.
You know, it doesn't actually work with user relationships and inactive relationships. It's something that we could add in the future. We've done the design so that we could actually make it work, but it doesn't currently work with user relationships and inactive relationships. And with regard to the all DAX function, I'd really have to look at the specifics. Ultimately, if you think of it logically, the query plan is going to create a logical query plan that's going to fold every single sum, min, max, and count down to the individual sum, min, max, or count. And then it will say, is this sum, min, max, or count at the granularity that can hit the cache or not? So depending on whether you're using the all DAX function, that may change things, right? So you'd have to look at the specifics.
Got it. Another quick one, is RLS supported with SSAS?
Yes, RLS is supported with SSAS, but aggregations is not. Yeah,
sure.
Okay.
Yes.
Yes.
So RLS specific.
Yeah.
And the last one that I have is, what would be the way to get the best performance out of on-prem SQL Server tables with 500 million plus rows with aggregations? Does going through gateway affect performance?
Okay, so gateway is going to affect the performance of the direct queries, just as it would without aggregations, just as it would without composite models. Obviously, you can mitigate that somewhat using aggregations, because if it's a direct query that is going to hit an aggregation table, that would be faster by its nature. It's going to be hitting the aggregation table. It's going to retrieve less data potentially in some cases. And in other cases, you can have the in-memory aggregation so that it doesn't need to submit the direct query through the gateway at all, right? So you can help mitigate that. But when it goes through the gateway, it's going to work the same as regular direct query ultimately.
Got it.
Okay.
Perfect. I think, sorry, I'm just going through all this to make sure.
Yeah, same with us, we're making sure.
Okay.
Yes.
Thanks. That one. Let's go to the publish.
Okay, I think we did address.
I think we have.
Yes.
All right.
And if we haven't addressed your questions, please know that we are going to go through them and make sure that we have addressed them.
Yeah.
And any that we haven't addressed, we will post to the blog.
Yes.
I think we'll also post these questions as well. So there's an FAQ.
Yeah,
So
I think
people
they're
can-
going to be in the recording as well. So we'll definitely post the recording, and I think it will contain the questions. Yeah.
Absolutely.
Right. And and Kelly, as you said, the ones that we we did not address here, if there are other ones, we'll make sure they're just in the blog and we'll there.
Okay.
So I think well, that was absolutely brilliant. Number one. So thank you very
Awesome.
much.
Thank you,
Super excited.
Kelly and Vijay. Thank you for your help.
And remembering that it will be generally available in the July release.
Yes.
Okay,
absolutely.
we will have the links posted. And remember, the new aggregations for petabyte scale datasets will be generally available in Power BI desktop release in probably close to the end of July.
Or mid-July.
Mid-July. Watch out for Amanda Kovsky's blog post on the Power BI blog. And big thank you for Christian Wade of Microsoft for educating us on this great new feature. And thank you, Vijay, for being a great producer here and supporting us with the questions and answers as well. Your expertise.
Right, Kelly.
Thank you so
Thank
much.
you, Christian.
Thank you, Kelly. Thank you, Vijay. Appreciate it.
Thank you, everyone,
Thank you.
for joining us.
Thanks, everyone, for joining us. And go and unlock some massive data sets for your customers and enjoy it. Okay, thanks.
Bye.
Bye.